Welcome back. This is Piecewise Functions. So we're sketching graphs with piecewise functions and identifying some of its key features by using what we know about graphs of the parent functions. So we have piecewise functions. So those are functions created using pieces of other functions. So it says, sketch the graph of the piecewise function. Use the graph to identify the domain and range of the function and evaluate the function at a given value. So when graphing piecewise functions, we look at the function and its restricted value. So we're wanting 2x where x is less than 3. So at 3, we're going to draw like an imaginary line. So I'm just going to highlight because that's going to be my imaginary line. So at 3, we want everything on this side for that graph. So we don't want anything on this right-hand side. So we want to figure out what value is when x is 3. So, and that's going to be like your starting point or you're going back to from point. So 3. So 2 times 3 is 6. So at 3, 1, 2, 3, 4, 5, 6, you're going to have an open circle because we're not equal to for our inequality. All right, and then you could go backwards. So 2 times 2 is 4. So 3, 6, 2, 4. Basically, it's going to go down 2 over 1. Down 2 over 1. And then you can plot that point. So at 2, 1, you should be at 2. So 2, 2. Or 1, 2. 1, 2. And then at 0, we're at 0. Basically, so you're just going to go follow that down 2 over 1 until you keep going. So there's an arrow at the end because we can be anything on that side. All right, then the next one, so x plus 1 greater than or equal to 3. So when it's 3, we're going to add 1, so it'd be 4. So at 3, 4. So 1, 2, 3, 4. It's going to be a solid circle because we're equal to. And then we want everything above. So 4 plus 1 is 5. So at 4, we're at 5. And then it's just going to go up 1 as we go. Up 1 over 1, up 1 over 1 until we get here. And you can check your points. So 5 plus 1, that's going to be 6. So 5, 6, it just means it's going up 1 more than it is. All right, so our domain. So domain is going to be negative infinity. Oh, it erased it. So negative infinity 2. And then we look, is our hole filled in? So if we were like to smash it into one line, we look, there is a hole. We fill in that value. Let's see. That's not what I wanted. So we fill in that value here. So like if it were like a flat line, we fill it in with this hole, with this filled in circle here. So it actually will be negative infinity to infinity. There's no gap. So there's no gaps or real holes because those holes get filled in by another point. Same with our range. That gets filled in here. So it will also be negative infinity to infinity. All right, then it says f at 5. So when x is 5, what's our value? So remember our imaginary line here. So it's going to be this second graph because it's a value bigger than 3. So then at 5, we were 6. All right, next one. So we have negative 2x plus 1, negative 3 to negative 1. So that means, so at negative 3, we're going to have like an imaginary line. And then at 1, we also have our imaginary line. So it's going to be bound within those two lines. So we need to find out what the value is at negative 3. So negative 2, negative 3 plus 1. So 6 plus 1, which is 7. 2, 3, 4, 5, 6, 7. Oh, and then it's going to be an open circle. Because, or no, close. It is equal to. Then we find negative 2. So 4 plus 1, that's going to be 5. So down 2. Down 2 over 1. Down 2 over 1. Down 2 over 1. So then we'll find out what 1 is. So negative 2 times 1 is negative 2 plus 1, which is negative 1. So negative 3, 7, negative 2, 5, and 1, negative 1. Oh, excuse me, sorry. I forgot to pause for my sneeze. Okay. So, it's our line here. And then from 1 to infinity, so on the other side, where x is greater than 1, it's the x squared. So x squared. So at 1, so 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9. So at 1, we're at 1, and we're going to be a solid circle. And then at 2, and then at 3, we're at 9. 2, 3, 8, 9. And then we just keep going towards infinity. So it's kind of curved a little bit. It's hard to get that curve. Okay. All right, so for domain, we have a starting point. We don't have an arrow here, so it's going to be negative 3 with the bracket. And then we fill in the hole here, and then we go to infinity because we have an arrow at the end of our graph. And then the range, so we start at a hole, and then we don't have any holes or gaps in between going up. So we start at parenthesis, because it's an open circle, at negative 1, and then we go to infinity because we have that arrow again going right and up. All right, f at 0. So at 0, that's going to be between negative 3 and 1. So that would be negative 2 times 0 plus 1. So it's going to be at 1. And you can also tell by the graph here too, that little green mark is where f is 0. All right, let's look at the next one. So we have x to the third from -2 to +1. So in between these lines here. And then from 1 to 4. So we're going to end our graph at 4. All right. So x to the third, so from -2, so we've got to start at -2 to the third, which is going to be -8. -1 is going to be -1. 0 is going to be 0. Then 1 to the third is 1. So -2, -8, -1, -1, 0, 0, and then 1, 1. So -2, -8, so down here, and it's going to be a closed circle here. And then -1, 1, 0, and then 1, 1 is going to be an open circle. So we go up. Like that. All right, then from 1 to 4, we're the 3x plus 2. So draw a little squiggly. So 3 times 1 plus 2 is 3 plus 2, which is 5. So 1, 5. So at 1, 1, 2, 3, 4, 5. And it's a closed circle. And then at 2, so 6 plus 2 is 8. So 2, 8. Then at 3, so 11, which is here, and 4, so 12 plus 2, which is 14. So 4, 14, 3, 11. And it's going to be a closed circle. So this is 4, 14 is up here. All right. So domain. So starting with a closed, and that was at -2. And then we fill in the gap here. So that's filled in. And then we end at 4. And then our range. So bottom to top. Well, we don't have anything in the middle. So there's a big gap in the middle. So we start at -8. And then we end at 1 with the parenthesis because of open circle. And then we start up again at 5. And then we go to 14. Because remember, we only want in between -2 and 4 for our x values. So we stop at that point. All right, next we're doing a piecewise function from the graph. So that means we're going to have 3 sections, and then we have like our intervals over here. So let's start with the intervals. Those will be easy. So from -infinity to 1. So x is less than or equal to, because we're equal to, we have a closed circle here. Oh, at -1. And then from -1 to 1. So you write it as -1 less than x less than 1. So that's in between. And then x is greater than or equal to 1, because it has that closed circle here. All right, then we do our lines. So this one, it looks like we went over 1. So to the left 1 and up 1. Or actually, this would be up 2. Because if we kept going, it would hit at 2. Because if we went, because it looks like the slope. So it's over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. So it'd be 1x plus 2. So remember, our lines are y equals mx plus b. So m is the slope, and b is the y-intercept. And remember, slope also, we could have found 2 points like here and here and found the average rate of change. So y2 minus y1 over x2 minus x1. So -1 minus a -2 over 3, -3 minus a -4. So it's 1 over 1. Okay, so you can do it that way too. And we might have to do it with these, but maybe not. All right, so for this one, we do have a y-intercept here. So that's at 1, 2, 3. So plus 3. And then we go up 1 over 1, up 1 over 1. So still 1x. Or you can just write them x. All right. Or you can find the slope of the line between the 2 points. So -1, 2. And then the next point was 1, 1, 4. So -1. Oh, no, this one's right. Okay. So 4 minus 2 and 1 minus a -1, because it's the 1 minus a -1. So 4 minus 2 is 2 over 2, which is 1. So slope of 1. All right, then the next one, it looks like it's up 1 over 1. for the slope, so 1x. And then if we went down 1 over 1, it would be plus 1 for our intercept. All right, and we don't need to include the 1. So there we have it. There is our piecewise. And then if we were to do the domain and range, so domain, so those fill in, so negative infinity to infinity, range, same thing, those fill in. Oh, except, nope, we have a gap here. So it'd be negative infinity to 1. And then those fill in. So then from 2 to infinity. Because those would fill in here. All right. Next one. So these are the points that you're going to be looking at for your graph here. So let's see, 1, 2, so f of x. So from negative infinity to 2, or this line here. So x is less than or equal to 2. Then here we're from 2 to 2. And we're equal because we're solid. And then from 2 to infinity, so x is greater than or equal to 2. All right, same thing, you can use that slope formula, or you can do your up 1 over 1s. Or, so you start at this point down here, and then to get to the next point here, so we go up 3 over 1. 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 And that's where we'll hit the, so this would be 11. And then up 3, that would be 14. Up here. But you can find your y-intercept. So if you have your slope, so it's up 3 over 1, so it's 3x. So y equals 3x plus b. So then you just plug in a point. So here we have, so this will be 1, 2, 3, 4, 5, negative 5. And then this is 1, 2, 3, 4, 5. Also negative 5. So we put in negative 5 in for both of those. And you're going to get your b value, or your y-intercept. So negative 15. Oh, that's not 10. This is 1, 2, 3, 4, 5. This would be 6. So that would have been 7 plus 3 is 10 up there for the up 3 over 1s. Plus b. So we add 15. So 10 equals your b. So it'd be 3x plus 10. All right, the next one, it's a straight line at 1, 2, 3, 4. So it's just equal to 4. So if you were to like graph this on your calculator, if you put in y equals 4, it's just going to be that straight horizontal line in either direction. All right, then the next one is pretty similar to this other one. So except for it's going in the opposite direction. So it's going down 3. So 1, 2, 3 over 1. Down 3 over 1. Down 3 over 1. So it's going to be a negative 3x plus b. All right, then we plug in our points. So you can choose the 2, 4, 2, 4 if you want. This point here. Or 3, 1. It doesn't matter. They're going to get you that same b value. So this one was 4, and this one was 2. So 4 equals negative 3 times 2 plus b. So 4 equals negative 10. Oh, that's what our answer is going to be. Negative 6 plus 6. So 10 equals b. So it's going to be negative plus 10. Maybe. And it closed out. I was going to show you the graph. Let's see. Now it's doing weird things. So clear. So if we put in 4, we graph it. See, it's just that straight line. Now let's go back to the notes, and hopefully it's in that same spot that we left it at. Oh, it went up. Okay. No, it's not a problem. All right, so that's negative 3x plus 10. And you could do that so you could go up 3 over 1, which is 7. And then up 3 over 1, which will be 10. So kind of in that same spot, they would cross eventually, going in that direction. All right. Oh, plus 10. And you can also use your slope formula to find your slope. And then the y equals mx plus b to find your b value or your y-intercept if you didn't want to count how many up and over you go. All right, and that is it for Piecewise. Go ahead and work on your assignment and let me know if you have any questions.